Hello and welcome. In this video, we're going to be solving yet another super tough mechanics question. This is from the May-June 2018 paper 42 question. And what's really interesting is that part 2i is actually a 9 marker. And I don't remember seeing any other 9 marks part except for this question. So this should be interesting. Let's start by reading the question and see how we will attempt this question. So it says that as shown in the diagram, particle A of mass 1.6 kilograms lies on a horizontal plane and B of mass 2.4 kilograms lies on an inclined plane at an angle of 30 degrees to the horizontal. The particles are connected by a light, inextensible string. The word light is a super important keyword that tells me that the tensions at both sides of the string, so we have two objects here, yeah? A is going to be experiencing tension that way, B is going to be experiencing tension that way. The word light tells me that the tension that A is going to experience is the same as the tension that B is going to experience. And likewise, inextensible tells me that the acceleration on both sides of the string are also equal. So if A is accelerating to the right and B is accelerating down the plane, they will have the same magnitude. And also the change or the displacements is going to be the same. If B moved 0.5 meters down, A will move 0.5 meters to the right. These are all super important keywords, which, by the way, I have a full mechanics course on Udemy that I go through every single topic for Edexcel, Cambridge, for everything. It's literally a one-stop thing you will need for your mechanics test. It's designed to replace expensive tuitions. I'll leave a link to it on the top right-hand corner. If you're interested, send me an email and I'll send you a discount code. It's a very professional and well-designed course to help you get your mark in mechanics. So let's continue. What I have is, okay, so we said light inextensible string which passes over a small smooth pulley. Small means pulley doesn't have a mass, smooth means pulley doesn't have friction, and it's fixed on the top of the inclined plane. The distance AP is 2.5 meters. Distance B from the bottom of the inclined plane is 1 meter. So this distance over here is 1 meter. There is a barrier at the bottom of the inclined plane, this one, preventing any further motion of B. So when B falls down, it's going to hit this barrier and it's not going to continue moving. This is going to come of importance later on. The part BP of the string is parallel to the line of greatest slope of the inclined plane. The particles are released from rest with both parts of the string taut. Given that both planes are smooth tells me that there will be no friction in the plane. Find the acceleration of A and the tension in the string. So as always, in these questions, you always have a set of steps that you need to follow. The first thing is always to draw a free body diagram for the bodies that you have. So this is the pulley. This is A. It's connected with a string that is also connected to B. Let's put B over here. So this is A, this is B. Let's draw the free body diagram for A. So what are the forces acting on A? I'll have the weight acting straight down, and it's going to be of magnitude mass times G, 1.6 G. For Cambridge, you take G as 10 meter per second squared. This is a Cambridge question, so we're going to take it like this. If you're doing Edexcel, it's 9.81. So for A, we have the weight acting, and obviously we will have a reaction force, or some people call it the normal force. I'll call it R. What else? I will have the tension from the string on A. So A is being pulled to the right, tension is going to be to the right. Any other force? If you told me friction, I'll tell you you're wrong because the planes are smooth. And A is having an acceleration to the right, a value of, let's say, A. Okay, now we're done with A. We drew all the forces and we draw any accelerations. Let's move on to B. So B is having a mass of 2.4, so it will have a weight straight down, 2.4 G. It will have a normal reaction force, which is going to be always perpendicular to your plane. So if the plane is like this, the normal is going to be perpendicular to it. Let's call it R as well. Let's not confuse the R, so let's call this R dash or whatever, or let's call it RB. Okay, we will have the tension that is acting on B. Imagine you are B, the rope is trying to pull you, or like you're experiencing something that is pulling you up, so the tension is acting this way. Now, for A, obviously, I'm going to use this coordinate system. I'm going to have X as horizontal, Y as vertical. However, we know whenever we have an incline, our axis change. So for B, we're going to have our X, the direction parallel to the slope, and the Y, the direction perpendicular to the slope. So why do I do this? Because I will need all the forces to align to these two axes. If I look at the tension, it's already in the X direction. If I look at the reaction force or the normal force, it is in the Y direction. The only force that's giving me trouble is the weight, so I will need to resolve it into two components. I know that this is 30 degrees. So if I draw my axes like this, I know that the weight is going to have two components, one in the Y direction and one in the X direction over here. And I know if this is 30 degrees, then this angle is also going to be 30 degrees. So let's start from the force going into my angle is going to be cosine. So this part is going to be 2.4 G cosine 30. And then going away from my angle is going to be sine. So I don't know what happened. So this part is going to be 2.4 G sine 30. And I have an acceleration for B downwards as well, and it's going to be equal to A, equal to the acceleration of the first particle. So now I have my free body diagrams. I'm ready to use my equations. Right here, let me start with particle A. I'm going to resolve in the X direction. Okay, always take the direction of acceleration as the positive direction. If you're resolving in the X axis, you have two options, either right being positive or left being positive. How to know which one should you choose? Always follow the direction of acceleration. Okay, even if the particle is moving the other way, okay, and the acceleration is the direction that you should take as positive. So since the acceleration is to the right, I'm going to take my positive direction to the right. So let's think. A is having acceleration, so it's a case of sigma F, or sum of forces, is going to equal mass times acceleration. If A was in equilibrium, then it would have been sigma F equals 0. Okay, so sigma F in the X direction equals mass times acceleration. So let's do that. So tension is the only force on the X direction, and it's going to be positive because it's to the right. So tension, I don't have any other force, so that's it. It's going to equal mass, which is 1.6 kilograms, times acceleration, which is A. So this is my first equation over here. I do not need to resolve in the Y direction for A because it's not going to help me at all. I'm just going to get the reaction force equal to 1.6 G, which is not important to me right now. Whenever there is friction, then the reaction force is important because we know friction is equal to mu times R. So that's how you will get R into the equation. But here, since it's smooth, I don't need to. Okay, let's do the same for B. So let's resolve particle B in the X direction, taking down the slope as positive or up the slope as positive. Think about it. If you said down the slope, you will be correct because the acceleration for B is down the slope. And it's a case of sigma F equals mass times acceleration. So what's the force acting down the slope? I'm just going to be 2.4 G sine 30. And then I have tension, but in the negative direction, so minus T. Why negative? Because my down the slope direction is positive. Equals, that's it. I don't have any other forces in this X direction, so that's it. These are the sigma forces. Equals mass, which is 2.4, times acceleration, which is A. So from here, this is my second equation. From here, I can solve for T and A. So straight away, I see that I can substitute 1.6A into this T. So let's do that. I'm going to have 2.4 sine 30 is 0.5. So 2.4 divided 2 is 1.2 G minus tension, which I can replace with 1.6a, is going to equal 2.4a. Moving this to the other side, I'm going to have 1.2g equals 2.4a plus 1.6a. So 1.2g equals, I think, 4a. So 1.2 times 10 over 4 over 4. A is going to equal 3 meter per second squared. Okay, and then I can use this A over here to find the tension. So the tension is going to equal 1.6 times 3, which is going to give me an answer of 4.8 newtons. So my tension is going to equal 4.8 newtons. And this is my answer to the first part. It's a 5 marks part. Okay, let's move to double I and see what's it about. So it's given instead that the horizontal plane is now rough. So now I know that the horizontal part, this part, is now rough. So I can know that there will be friction in that part. Okay, whenever you have anything that changes, you need to redraw your free body diagram and never use anything from the previous part. I cannot say, okay, that the tension in the second part is going to be 4.8 or the acceleration is going to be 3. No, if something changes, everything changes, except the things that are like properties like mu or the masses or these things doesn't change. Okay, so it's given that the horizontal part is now rough. Coefficient of friction, mu, is 0.2. The inclined plane is still smooth. Find the total distance traveled. So let's redraw everything. So we have this part and we have that part. This is the barrier over here. We have A over here, we have the pulley, and we have B over here. There is a string connecting the particles. A is having a mass of 1.6, a weight of 1.6 g. We're gonna have a reaction force. We're gonna have tension to the right. And what's new here is that I'm gonna have a friction force. If A is moving to the right, then friction is gonna be to the left, and is going to equal mu r. Is going to be maximum friction, which has a distinctive equation that is given by mu r. Why is it maximum friction? Because it's already moving. Whenever a particle is moving, or it's on the point of moving or point of sliding, then the friction is going to be equal to mu r. And this is the tension over here. Okay. For B, let's do the same. Again, B didn't change at all. I have the weight down, 2.4 g. I'm gonna have the normal reaction, let's call it RB, and I'm gonna have the tension over here. There will be no friction here because the inclined plane is still smooth. So let's do our resolving. So this is 30 degrees. I'm gonna have a component down the slope, which is gonna be, and another component perpendicular to the slope. This angle is 30 degrees. So this is 2.4 g cosine 30, and this is 2.4 g sine 30. I have acceleration this way for A and acceleration that way for B, and they are the same. The question tells me find the total distance traveled by A. Okay, now this is super important. So let's think what's gonna happen here. So starting from the beginning, what's gonna happen is that B is gonna start moving down. A is gonna be dragged due to the friction. Okay, they're both gonna accelerate until B hits this barrier. When B hits the barrier, B is gonna stop. So what do you think is the string going to be? Is it gonna be still taut or is it gonna become slack? Obviously, it's gonna become slack, right? So the string right here is gonna look something like this. It's not gonna be stretched, right? So if there is no stretch or the string is not taut, then the tension now is 0. So we had this tension that was pulling A, but once B hits the barrier, this tension on A is gone. So we need to divide our question into 2 parts. Okay, we need to divide our question into 2 parts. The first part was this part over here. So what can we get from this part? We can get the acceleration, because if I want to find the total distance traveled by A, first of all, I know that B is gonna move 1 meter down, right? So since the string is inextensible, A is also gonna move 1 meter to the right. So A is going to be here. When A is here, then there will no longer be tension. However, A is going to be moving to the right with some velocity V, right? And it's going to continue moving due to its inertia. It's going to keep moving, and the friction is going to be on the other direction until it stops, let's say, over here. So I need to find this whole distance. So to find this whole distance, I need to know V. I need to know how much is the value of V, how much is A going to be moving when B hits the barrier. So to know V, obviously it's kinematics, so I will need to use Saviot. So something super important that I need to get is acceleration. So how do we get acceleration? From here. So let's do the same again. Let's start resolving particle A. Let's resolve in the Y first, okay? Taking upwards as positive, let's say. Okay, now in the Y direction, for A, I do not have any acceleration in the Y. So sigma Fy is not going to equal to ma, it's going to equal to 0. It's technically equal to ma, but A is 0, so it's just equal to 0, right? Or in other words, whenever I have sigma Fy equals 0, it means that the upward forces are equal to the downward forces. So straight away I can say that the upward reaction is going to equal to the 1.6 G. Forces balance, or it's in equilibrium in the Y direction. However, in the, okay, so let's resolve again A. However, in the X direction, and I will take the direction of acceleration as positive, so right is going to be positive. This is a case of sigma F equals mass times acceleration. So let's do it over here. So to the right, I'm going to have tension is going to be a positive value, okay? And then mu r is acting to the left, so it's going to be minus mu r. No other forces in the X direction, so I'll just equate it to m, which is 1.6 times A. Now, from this equation number 1, I know that r is 1.6 G. And I was given mu as 0.2. So I can change these into this equation. So I'm going to have T minus, instead of mu, I'm going to put in 0.2. And instead of R, I'm going to put in 1.6 G equal to 1.6 A. And this is going to be my second equation over here. So to find the acceleration, as we agreed, I will need another equation in terms of T and A to solve them simultaneously. And I can get this using particle B. So resolving particle B, since there is no friction in particle B, I do not really need to resolve in the Y direction. I don't need to resolve, it's not gonna help me. Okay, I'm just gonna know that the reaction is equal to 2.4 G cosine 30, but then I'm not gonna do anything with it. If the question asks for the reaction, you can do it, but for now I don't need. So I'm just gonna do sigma Fx direction. This is a case of equal to ma because we have acceleration. Straight away I'm gonna take down the slope as positive, again because the direction of acceleration is down the slope. So force down the slope is 2.4 G sine 30, and then I have the tension up the slope, so minus T is going to equal to the mass, which is 2.4 times the acceleration. This is my third equation, and now I can solve equation number 2 and equation number 3 together. So equation number 2, I can multiply 0.2 to 1.6. That's going to give me 0.32 G, and move it to the other side, so it's going to become plus. So I'm going to have tension on the left side equals 0.32 G plus 1.6 A. And then I can use this tension, substitute it over here to find the acceleration. So let's do that. So I'm going to have 2.4 G sine 30 minus tension, which is 0.32 G plus 1.6 A. And that is going to equal 2.4 A. So now 2.4 G sine 30, I know 2.4 times sine 30 is 1.2 G, and then I'm going to have a minus 0.32 G. I'm going to substitute this, distribute this minus inside, and then I'm going to have minus 1.6 A equals 2.4 A. 1.2 minus 0.32, that is 0.88 G. I'm going to move this to the other side, it's going to become plus. So 2.4 plus 1.6 is going to equal 4a. So a is going to equal 0.88 g over 4, and this is going to give me an answer of, I'm taking g as 10 over 4, that's going to give me an acceleration of 2.2 meter per second squared. So this is the acceleration for A and B in the first part. So they're moving with an acceleration of 2.2 meter per second squared. Now, I want to find the total distance traveled by A. First of all, B is gonna move this distance, which is 1 meter, until it stops. So when B moves this distance of 1 meter, obviously A is also gonna move a distance of 1 meter. So A is gonna be over here, 1 meter, with an acceleration of 2.2 and some final velocity v, which I need to get. So what I can do is I can just draw it super quickly over here. A was starting here and then it moved 1 meter. A became in this position. B started here and it moved 1 meter. So B is now here. 1 meter. This is 1 meter. Now, I need to get what is the velocity that A is moving with. So now I can use Saviot equations. Saviot equations. Okay, what I like to do is I like to write all the equations. Okay, so in front of S, which is displacement, I'm gonna write the equation that doesn't include the letter S, which is V equals U plus AT. I'm gonna do the same for the rest. So over here we have S equals U plus V over 2t. Over here I have S equals ut plus half at squared. S equals vt minus half at squared. This one you don't use a lot at all. This is v squared equals u squared plus 2as. Okay, straight away, let's think about particle A over here. So particle A, what do I have? Let's take the right direction as positive. For A, I know that my initial velocity is 0 meters per second for A. That's, by the way, that's before B hits the barrier. Okay, so U for A is 0. I have acceleration for A, I just found as 2.2 meter per second squared. I have the displacement 1 meter to the right, and I need to find, as we talked, the final velocity. So I mentioned U, A, S, and V. These are 4 letters of importance to me. Which letter didn't I mention out of the 5? I didn't mention time, so straight away I'm going to use the equation in front of time. This is how I solve, and this is how I determine which equation to use. So V squared equals U squared, which is 0 squared, plus 2 times acceleration times 1. So V squared is going to be the square root of this. So V is going to equal square root of 2 times 2.2 times 1, which is going to be 2.098 meter per second. So this is the velocity that A will be moving with, 2.098 meter per second, when B hits the barrier. So this is the velocity that A is moving with, and up until now A moved 1 meter. Now let's think about the scenario after B hits the barrier. What's gonna happen? If this is A is now here. Now, what are the forces acting on A? We said when B hits the barrier, the string is going to become slack, so there will be no tension in the whole string. So A is not going to be experiencing any tension, but B is going to be moving to the right. So forces acting is going to be the weight, which is 1.6 g, the normal reaction, a new normal reaction because something changed, so everything should change, and we will have the friction to the right equals to mu r. And how do you think the acceleration is going to be? Acceleration always follows the resultant force, and in the x direction I don't have any force except the mu r, and it's acting to the left, so I'm gonna have the acceleration to the left. And this makes sense. If I'm moving to the right and the acceleration is to the left, I'm gonna slow down, and you expect the particle is not gonna move on forever. When you throw a ball, it doesn't move on forever. It's gonna stop due to the deceleration, due to the friction force. So over here I can apply sigma f of x equals ma. I will have the left direction as positive. Okay, sir, the particle is moving to the right. Why am I taking left as positive? Again, whenever we're doing sigma f equals ma, your acceleration direction should be the positive direction. Okay? Only in sigma f equals ma. You don't need to do it in kinematics, by the way. Okay? So let's take left as positive. Okay, so I'm gonna have mu r is pointing to the left, so it's just 0.2 times. Okay, r, I could have done sigma fy equals 0, and from here I know that r is going to equal 1.6 g. So mu times r, which is 1.6 g, is going to equal the mass, which is 1.6 times the acceleration. I can see that 1.6 and 1.6 will cancel. 0.2 times 10 is basically 2 equals a, so a equals 2 meters per second squared, and it's acting to the left. So that is my acceleration. Now let's do kinematics again for particle A to see how much is it gonna move, what's the distance that it's gonna move. So again, let's start by doing, okay, for kinematics, let me show you. Okay, acceleration to the left, but in kinematics I can use any direction however I want. Let's take right as positive. So I know that my acceleration is going to be negative 2 meters per second squared because it's acting to the left, and I took right as positive for the kinematics. What is my u? What's my initial velocity? It's going to be my v, or the velocity that A was moving at this instant. That's why I found v. This is super important. And v is pointing to the right, so it's going to be positive 2.098 meters per second. What is my final velocity? I want to know until A stops. So when A stops, it means that its velocity is 0, and I want the displacement. So again, which letter I didn't mention? I didn't mention the letter T again, so I'm going to use this equation, v squared equals u squared plus 2as. So v squared, which is 0 squared, equals u squared, which is 2.098 squared, plus 2 times acceleration, which is negative 2, times s, which is the thing that I want. So I'm going to move this to the other side. It's going to become negative 2.098 squared equals negative 4s. The negative and the negative will cancel. Divide 4, divide 4. So s is going to equal 2.098 squared over 4. S is going to equal 1.1 meters. So this is the distance that A is going to move after the string is being slack and is just moving due to inertia. So it's going to move another 1.1 meter. So the total distance that A moved is going to be 1 plus 1.1 meter, which is going to equal 2.1 meters. That is the total distance that A traveled. Let's see, is it gonna hit the pulley? No, from here to there is gonna move 2.1 meters, and the pulley is 2.5 meters away, so it's not gonna hit pulley, because sometimes they ask you this question. Anyways, I hope this was helpful. Please don't forget to check the Udemy link down below. It's super helpful, guys, and I'm going to be giving it out also for free for some people. So you just email me, and if you're lucky, I'm just going to send it to you. Please leave any questions or comments you have down below. Leave a like and subscribe. They help immensely for me to keep on doing videos for you guys. Anyways, hope this helps. Thank you so much for watching, and have a good day.